Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 2976, which is minimum cost to convert string 1. Let's see the problem description. You are given two zero index string source and target, both of length n and consisting of lowercase English letters. You are also given two zero index character arrays, original and change, and integer array cost, where cost I represent the cost of changing the character original I to the character changed I. Okay, and you start with the string source. In one operation you can pick a character x from the string and change it to the character y at cost z if there exists any index j such that cost j is z, original j is x, and changed j is y. Return the minimum cost to convert the string source to string target using any number of operations. If it is impossible to convert source to target, return -1. Note that there may exist ij such that original I equal to original j and change j is equal to changed I. So ultimately, the problem statement says we have to change the source to target, and if it is not possible, so we have to return -1. And we are given two character array, which is original and change. Both are same length, and a integer array, which is cost, that is also same as the length of original and change. And to convert the each character, like changed I to original I to changed I, we need the it cost like cost of I. So let me discuss the algorithm with you. So first we need to find uh, all characters, like from all character, like from A to all other characters, the minimum cost to convert. Okay, let's see the constant first. Constant says the length will be target and the source will be equal, and it will be 1 to 10 to the 5, and both consist of lowercase English characters, and these are same length, and it will be less than 2000, and cost of I is less equal to 10 to the 6, and original I not equal to original I not equal to changed I. Okay, so the algorithm is like that. We have to find all minimum cost from all character to all the other characters. So what we will use? We will use Floyd Warshall algorithm to find the minimum cost from each character to any other characters. Okay, then we'll calculate the traverse the source string, and we check in each index if source and target is not equal, and if it is possible to change the character of source to target, then we will increase the answer with the minimum cost that we have got previously from the Floyd Warshall algorithm. Okay, the algorithm will be like this. So let's see how the code will look like. So first we will create like n equal to, let's say, original dot size, and we will create a 2D array which is vector int, not int, like we have to use long because the return type is long. So first I will use using ll equal to long. So we don't have to write long again and again. We will write ll instead of, let's say, ll is this, and vector ll, let's say dp. I am saying this is the dp, or you can say array of vc, like anything vc, let's say, because all the characters will be lowercase English letters. So the size of the vector 2D vector will be 26 cross 26. Okay, vector of ll of 26 size, and initially we know We have to keep all the values as infinite. Let's say the infinite is value is long max ll long max, and we keep as infinite all the values. Then we traverse the original changed and cost to store the values which we are given. So for int I equal to slot int equal to 0, I less than n, I plus plus, n is the size of polynomial, let's say, keep it here. So the original is, let's say, I1 equal to original minus original of I minus a. This is the index row, like the row number, and overall I2 is changed of I minus a. This is the column number, and what is the cost? Cost is, let's say, C is the cost. Cost is cost of I. And what we will do, we will store VC of ij, not ij, I1j, I2. How am I2? To the minimum of VC of I1, I2 means which is previously stored, and the new cost which is C. Okay. After this for loop, we got all the given values we stored in the our vector 2D array or 2D vector. Now we have to apply the Floyd Warshall to find all the minimum cost from like one character to any other character. So what we will do, Floyd Warshall algorithm looks like this. We will k equal to 0, k less than n. Here n is 26 because the size of the vector is 26 cross 26. So n is here 26, and k plus plus for I equal to 0 to I less than 26, and I plus plus for j equal to 0, j less than 26, j plus plus. First we will check if we see of ik is not equal to infinite, not equal to, sorry, and we see of kj is also not equal to im. Then what we will do, we see of ij equal to minimum of VC of ij, comma, the new distance which is VC of ik plus VC of kj. K is the intermediate node or intermediate character between I and j. Okay, so this is how the Floyd Warshall algorithm works. So after this for loop or this section, we got all the minimum cost from going from one character to any other character. So now we need to just keep track all the changed element, which is for type of 0, y less than, let's say, source and target. Source dot size I plus plus. We check, first check int I1 is the I1 is the index of source of I minus a to get the row number, and I2 is the column number which is the target target of I minus A. Okay, this is the column number, and we check if so source of I is not equal to target of I. Then we check if VC of I1, I2 not equal to infinite. If it is not infinite, then we just need to increase the answer with VC of I1, I2. If it is not infinite, then that means it is the minimum distance between I1 to I2. And else, if we can't change like source I, like source to target, if any character we found that we can't change, that means we have to return -1. That's it. So after that, we need to return the answer. Let's see, will it work? Let's submit it. So it is submitted. So it is submitted. So let me discuss the time and space complexities of this code. So this for loop is running n times, where n is the length of original, change or cost, anything, because the three of vectors length is equal. So n is uh, the length of original. And for this for loop, as it is, like you can see, this is running constant time. You can ignore this, because like it is running 26 times 26 times 26. It is like not depending on the size of any of the given vectors or strings. So you can ignore that. This is constant time. And this for loop is running n times, where n is the size of source. So you can say the overall time complexity of this algorithm is big of n plus m, where n is the number length of the source and m is the length of original. So, or you can say the time complexity is maximum of big of like source and destination, like whichever length is bigger, you can say that is the big of that length is the time complexity. And space complexity, we are using it to like 2D vector, so which is like 26 times 26. So this is a constant space, we can say, which is not depending on the length of any of the given array. So the space complexity, you can say, is constant. So that's it for today. See you in the next video.